Alright, folks. This is one I really don't look forward to recording. In fact, I'm not looking forward to recording the next handful of these. Because, as I have my Koroks gameplay footage playing, I am going to read out loud and go over my schoolwork. No, I'm not kidding. If you've been following my streams, it's what I've been doing lately. It's just because, well, let's face it, we all know I'm not going to study this on my own. We all know I'm not going to look through this material on my own. And so, if I read it on here, then that at least proves I am indeed going through my school material. Man, I've been dreading doing this for quite a while. And yes, in the game, I did go to the wrong shrine. Anyway, so let's get into it. I'm going to continue where I left off, and I don't even remember if I went through this, so I'm just going to go through it again, because I am behind like 3 weeks worth of material, and my midterm is like next week, so I need to start going through the material. I haven't even started studying yet. I'm going through the material for the first time. I am weeks behind. Anyways, let's get started. Okay, so, water heaters. Introduction to water heaters, fuel supply and venting systems, conventional tank types, high efficiency, combination systems, and tankless coils. We'll begin by looking at pressure versus flow, bracket important to grasp concept, then we'll move on to other. Oh boy, oh my god, I see so much to read. Provide hot water at 120 degrees Fahrenheit / 49 degrees Celsius to fixtures. Insulated steel cylinders with enamel coating on the inner surface, bracket referred to as glass-lined tanks. Life expectancy variable, but about 15 to 25 years. Similarities and differences between hot water boilers and water heaters. And this is kind of cut off here. Biggest difference is boilers are recirculating systems. Oh, the word systems was cut off. Well, that was all the bullet points on the slide, but there's a whole bunch of stuff to read at the bottom. Normal house water temperature, bracket cold line, is about 50 Fahrenheit or 10 degrees Celsius. For similarities and differences, see section 2.2, which I am not buying the textbook. Last point, hot water heaters heat fresh water where boilers recirculate the same water. Bracket, this water has less oxygen and is less corrosive. Alright, components and their functions. Water heaters are designed to provide hot, bracket, 200 degrees Fahrenheit / 49 degrees Celsius, water at fixtures such as sinks, basins, laundry tubs, bathtubs, and showers. We'll concentrate on the most common types, which are gas, oil, and electric. These heaters usually have storage tanks with capacities of 30 to 60 gallons. Most tanks are insulated steel cylinders with an enamel coating on the inner surface. They are referred to as glass-lined tanks. The lining helps, but does not absolutely prevent corrosion. Alright, other materials. Some water heaters tanks are copper, some are aluminum, and some are an alloy of copper and nickel. Some modern water tanks are plastic coated. The copper, aluminum, and copper-nickel alloy tanks all last longer than steel tanks. Some of these can last up to 50 years. Life expectancy. Conventional domestic water heaters have life expectancies that vary across North America. In some areas, life estimates are as low as 8 to 12 years. In other areas, life expectancies can be 15 to 25 years. Temperatures of hot water. Water heaters, or hot water heaters, as they are often, bracket, redundantly called, are designed to raise the water temperatures in the house from approximately 50 degrees Fahrenheit to 140 degrees Fahrenheit, bracket 10 degrees Celsius to 60 degrees Celsius. Modern thinking calls for domestic water no hotter. Wait. Let me read that again, but with proper phrasing. enunciation? I don't know. Modern thinking calls for domestic water no hotter than 120 degrees Fahrenheit, bracket 49 degrees Celsius, to avoid scalding. Most equipment manufacturers, installers, and local authorities now recommend 120 degrees Fahrenheit, bracket 49 degrees Celsius water. Fuels. Water heaters are similar to the residential hot water boilers used to heat houses. The fuel used to heat the water can be gas, oil, or electricity, for example. There are other systems including propane, and there are solar heating systems. We will focus on gas, oil, and electric systems. Similarities between hot water boilers for heating and for heating the home, and domestic water heaters for washing people, clothes, and dishes. Both systems have gas piping and a burner, bracket if gas, oil, or propane, or electrical wiring and immersion elements, bracket if electric, thermostatic controls, cold water inlet pipes, hot water outlet pipes, pressure relief valve, bracket often temperature/pressure relief on water heaters, venting system for exhaust products if there's a burner, a tank or container for the water, a heat exchanger to transfer heat from the burner to the water if it has a burner, a drain valve near the bottom, standby capabilities to keep water hot when the system is idle. There are some differences too. Let's look at these. Differences between hot water boilers and water heaters. 1. Boilers move the water in a loop. Boilers move the water in a loop. They recirculate the same water for a long time, while water heaters only see water once, bracket usually. 2. Boilers deliver water to radiators or some other heating device, while water heaters deliver water to fixtures, brackets sinks and bathtubs, and appliances, bracket clothes washers and dishwashers. 3. Boilers can operate at 180 degrees Fahrenheit or 82 degrees Celsius, while water heaters operate at 120 Fahrenheit 49 Celsius to 140 Fahrenheit 60 Celsius. 4. Boilers have a pressure relief valve set at 30 psi, and boilers have a high temperature limit switch set at 210 Fahrenheit or 99 degrees Celsius, while water heaters have a temperature/pressure relief valve set at 210 F, 99 C, and 150 psi. 5. Boilers have an expansion tank, bracket cushion tank. Water heaters don't. 6. Boilers use a circulating pump and or convection, brackets, that was in a bracket, to move water, while water heaters use the house supply plumbing pressure, typically 40 to 80 psi, to move water. I am so screwed for this midterm, even though it's online and I can have all the notes open. I am so screwed. 7. You can't drink the water from boilers, but you can drink the water from water heaters. 8. Boilers don't usually work in the summer, while water heaters work all year. 9. You have a wall thermostat to control the temperature of the home, while water heaters have a thermostat on the heater to control the water temperature. 10. Boilers don't have sacrificial metals to control corrosion, but water heaters use sacrificial anodes, bracket anti-corrosion rods, to slow the corrosion of the tank. 11. Water heater tanks are often glass-lined to control corrosion, while boilers never have glass liners. 12. Water heater tanks are insulated, while boilers may or may not have insulated shells. 13. Water heaters have an isolating value on the cold water supply, while boilers may have isolating values on the cold water inlet and hot water outlet. 14. In some areas, water heaters can be rented, but boilers usually can't be rented. And 15. Boilers are much more expensive than water heaters. That was only slide 4 out of 31. Alright, components and features. Sacrificial anodes are anti-corrosive rods to prevent water attacking the tank, usually magnesium or aluminum. Vacuum relief valves on cold water inlet to prevent cross connections. Water heater size is a function of its capacity and size of the burner. Bracket recovery rate. Alright, so, corrosion issues. Look at that, 40 rupees. How nice is that? That's why I always like fighting the Yigas, especially the small ones. Because they always drop rupees. The big ones, they only drop bananas. Okay, so. Yeah, corrosion issues. The water which circulates through a hot water heating system becomes chemically inert and does not rust the piping. Jeez, corner of my eye, I see an explosion. And of course I'm going to talk to this guy. This guy's always here. This Yiga's always here. I remember the first time I fought this Yiga, I was on a phone call with one of my friends. I was just like, oh my god, some kind of ninja in-game just attacked me. Look at that. Look at how many rupees I just got. Anyways, because water heaters see water only once and are constantly exposed to fresh water with lots of corrosion-causing oxygen, they are more prone to corrosion than hydronic heating systems. As a result, water heaters are usually provided with an anti-corrosion rod or sacrificial anode. Sacrificial anodes are typically magnesium. They sit in the tank water, allowing the chemical reaction from the water to attack them rather than the tank. Anyway, so I have a diagram in front of me. Sacrificial anode. The sacrificial anode, also called an anti-corrosive rod, is typically made of magnesium. It is used to attract corrosive elements so that the tank itself will not corrode as quickly. It can be replaced when it is badly corroded. Because water heaters see water only once and are constantly exposed to fresh water, they are more prone to corrosion. Alright, vacuum relief valve. Vacuum relief valves are installed in some jurisdictions to prevent hot water from backing into the cold water lines in the event of a cold water pressure drop. They also protect against possible collapse possible collapse of the storage tank by preventing a vacuum from forming inside. Alright, so prevents cross connections and prevents a vacuum inside the tank or possible collapse. Vacuum relief valves. Some water heaters are provided with a vacuum relief valve on the cold water inlet side. This helps avoid cross connections by preventing the hot water from backing into the cold water line in the event of the cold water pressure is low. The vacuum relief valve also protects against possible collapse of the storage tank by preventing a vacuum inside the tank. Vacuum relief valves are very common on the bottom of fed tanks, which have no dip tubes. Top fed tanks have dip tubes that provide some protection against siphoning via a hole drilled through the side of the tube near the top. This is not always completely effective. Vacuum relief valves can also prevent water from siphoning below the heating element when the house water pressure drops below the pressure in the water heater tank. Elements will burn out if exposed to the air. Oh, I think this is it. Here, hold on. I think this is the Korok. Hold on, take a look at this. Absolute failure. I climbed all the way up there just to completely fail. How nice. And then I said, why do I need to climb all the way back up? Why did I climb all the way up in the first place? Anyways, let me take a sip. Alright, gas and oil water heaters. Burner is located in the center and exhaust products... What? Okay, I misread that. Burner is located in the center and exhaust products go through the core and baffle to transfer heat. The tank is both the storage compartment and the heat exchanger. External flue heaters, or floating tanks in brackets, pass products through the bottom of the side of the tank. The dip tube introduces cold water near the bottom and hot water is drawn from the top. Alright, so gas and oil fired water heaters. Burner in center. On conventional gas or oil-fired water heaters, heat is generated by a burner at the bottom of the tank. The tank is a very tall donut with a hole up through the center part of the tank. The exhaust products from the burner go up through this core, and heat is transferred through the tank walls from the core into the water. The exhaust products go into a vent connector above the core and into a chimney or vent system. No separate heat exchanger. Domestic water heaters transfer heat directly from the combustion products through the tank wall and floor into the water. The tank is both the storage compartment and the heat exchanger. Most gas and oil domestic water heaters are center flue type. All of the combustion products go up through the center of the water heater. External flue water heaters are also available, although they are not common on single-family homes. Or just on single-family homes. There wasn't an A there. Gas water heater, and there is a diagram labeling all the parts, different components of the heater. Oil-fired water heater, another diagram labeling it all. Combustion chambers in oil water heaters are often ceramic fiber. External (floating) tank water heater (oil fired). Oil fired water heaters may be external or floating tank systems. This means that the combustion product pass over the entire bottom of the tank and through flue passage on the outside of the tank (between the tank and the outer wall of the water heater). Ceramic refractories. Combustion chambers in modern oil water heaters are often ceramic fiber. These combustion chambers are light and help reduce the weight of the water heater while providing for adequate heat control and heat transfer. These combustion chambers are These combustion chambers can typically be replaced if necessary without replacing the entire water heater. Ooh, there's a big paragraph here. Alright, the dip tube. Cold water is introduced through a dip tube near the bottom of the tank. The cold water supply pipes usually attaches to the tank at the top. The dip tube carries the cold water through the tank, discharging it near the bottom of the tank. The hot water is drawn off from the top of the tank. Sacrificial anode rods. Yeah, this is a big paragraph right here. Sacrificial anodes are typically magnesium, aluminum, or even a zinc and tin combination. And the anode material that is most suitable is a function of the water chemistry. The idea is that corrosive chemicals in the water will attack the anode rod rather than the tank itself. In some areas, these rods are replaced regularly to extend the life of the tank and reduce the poor odor and taste of the water. In other areas, the original rod is left in through the life of the water heater. The rate of deterioration of the anode is a function of both water chemistry and the water temperature in the tank. The higher the water temperature in the tank, the faster any chemical reaction will take place. Water heaters that keep water at 150 degrees Fahrenheit or 66 degrees Celsius will fail sooner than tanks with water stored at 120 Fahrenheit, 49 degrees Celsius. Some studies show that the difference in life expectancy is dramatic and that changing the water temperature from 140 degrees Fahrenheit to 160 degrees Fahrenheit, or 60 degrees Celsius to 71 degrees Celsius, will result in a life expectancy for the 160 degrees Celsius tank that's only about 60% of the life expectancy of the 140 degrees Fahrenheit tank. Alright, capacity or recovery rate. A measure of how many gallons of water can be heated by 90 degrees Fahrenheit or 50 degrees Celsius in 1 hour. Typically, recovery rates are 20 to 40 gallons per hour. Larger tanks are usually used with tanks that have a slower recovery rate to store more hot water. Oil water heaters have the highest recovery rate and electrical water heaters have the lowest. General rule: 60 gallons electric equals 40 gallons gas equals 20 gallons oil. Wow, this is interesting. Heated by 90 to 100 deg F. It's literally written like that. It's written out DEG and then capital F. When this whole time that has not been how it's been written. But anyways, heated by 90 to 100 degrees Fahrenheit will result from heating cold water from roughly 50 degrees Fahrenheit to 140 degrees Fahrenheit, or 10 degrees Celsius to 60 degrees Celsius. And also, heating in this sentence is capitalized for some reason. Recovery rates for oil-fired waters. I almost want to say oil-fried rice. Recovery rates for oil-fired water heaters can be 70 to 130 gallons per hour. Small tanks of 30 gallons will be fine in this case. Large burners have faster recovery rates. I am now only on slide 14 of 31. Anyways, so recovery rate, usually calculated as number of gallons that can be heated to 140 degrees Fahrenheit in 1 hour. E.g. 35 GPH. The faster the recovery rate, the smaller the tank. Size issues. The adequacy of size of a water heater is a function of the volume of hot water it can keep on hand, the size of the burner. The larger the burner, the faster the recovery rate of the heater. Relative recovery rates. Larger tanks would be used with Larger tanks would be used with tanks that have slower recovery rates. Electrical tanks are usually bigger than gas, which are usually bigger than oil water heaters. Once again, general rule: 60 gallon electric equals roughly 40 gallons gas equals roughly 20 gallons oil. Tank size and recovery rates can usually be found on a data plate. BTUs per hour compared to kilowatts. 1 BTU is the amount of heat required to raise the temperature of 1 pound of water by 1 degree Fahrenheit. So 1 kilowatt equals 3,412 BTUs per hour. Anyway, so define BTU. 1 kilowatt equals 3,412 BTUs per hour for electrical. Example: 4,500 watt water heater would produce about 15,000 BTUs per hour. Man, I already feel my throat starting to feel a little something. Pause. Just because of all this talking. Make sure you guys out there are staying hydrated. Electrical water heaters. There is no burner, heat exchanger, or venting system. They employ 2 immersion elements. The lower element heats cold water at the bottom and will not work simultaneously with the upper element. The upper element will come on when lower element is not sufficient, and it will heat water near the top. Normally, both heating elements don't work together. Both elements are thermostatically controlled. Thermostat is not normally visible without removing an access panel. Electric water heaters. Electric water heaters work on a different principle. There is no core in the center, since there is no burner. No heat exchanger or venting systems required. Electric water heaters typically employ two immersion elements that are similar to the elements in a kettle. One is near the top of the tank and the other is near the bottom. Both elements do not work at the same time. Note, there are some water heaters that have only one element. There are also some water heaters designed to have both elements on at the same time. Life can never be simple, can it? It actually says that. Oh my god, there's a lot to read here. Oh my god. Why did I choose to go back to school? You know, in all honesty, me failing this course may not be that big a deal, because I don't think I'm going to do the rest of the program. Then again, maybe one day if I do change my mind, and I did fail this, well, I gotta take it again, so shit, I'm screwed. Anyways, electric water heater, element sequencing. So, there's 4 diagrams here. So, diagram A, cold water being drawn into the bottom of the tank causes the lower element to come on. B, as the hot water is depleted, the priority, bracket upper, element comes on, shutting down the lower element. C, the upper element is satisfied so the lower element can turn back on and finish heating the rest of the tank. D, both elements are satisfied, the lower element turns off. Anyway, so it's kind of just saying, inside of a water heater there's 2 elements, like 2 things that turn on to heat the water, one at the bottom, one at the top. And, you know, once one side of the tank's water starts to get hot, then the other sides turn on and heats the other sides. Anyway, so, under normal use, the lower element works more often than the upper element. We can't tell if one element is burned out beyond scope of standard. Okay, thermostat control. Both elements are thermostatistically controlled, and the temperature setting is usually the same on the top and the bottom. A high limit switch, sometimes called the reset button, is usually attached to the lower thermostat on 2 element heaters and to the single thermostat under the lower access panel on a single element heater. It's a safety device that shuts off the power to the elements if either thermostat fails to shut off. It must be manually reset to reactivate, and is deliberately designed into the safety device to warn of a possible thermostat failure which could result in an explosion. Most professionals suggest that if the device has to be reset more than once, an unsafe condition exists and it requires servicing. The thermostats and high limit controls are not normally accessible without removing an access panel, and often some insulation. If the electric power to the water heater is on, and this next part is bolded, there is a risk of electric shock in removing these access panels and accessing the thermostats. There are live electrical connections adjacent to the thermostats. Unless you are comfortable and skilled working with electricity, you should leave these access panels closed. Home inspection standards don't ask us to remove these panels during an inspection. These elements provide the heat and, for the most part, the water configuration is the same as on a gas or oil system. Cold water is introduced near the bottom of the tank and hot water is drawn off near the top. The cold pipe may enter the top of the tank or the side of the tank near the bottom. Alright, lower element comes on first. How are we doing with the Koroks? Good so far? Good. When the tank is at rest, it will be filled with hot water. When a hot water faucet is turned on, hot water will be drawn off the top of the tank and cold water introduced at the bottom. This cold water near the bottom of the tank will activate the thermostat of the lower element. The lower element will come on and heat the incoming cool water. The upper element will still be surrounded with hot water and will be satisfied. Upper element has priority. If we keep drawing off hot water, the tank will be filled with cool water, because the lower heating element will not be able to warm the water up quickly enough as it comes in and flows through. Eventually, all of the hot water will be drawn out of the tank, and all of the water will be cold. At this point, the thermostats for the upper and lower heating elements will both be called to heat. The upper element has priority and will shut off the lower element so it can operate. As discussed, only one element can work at a time. Hurry to get some hot water. That's literally what's written here. The reason the upper element has priority is that after the tank has run out of hot water, we want to prepare quickly for the next use of hot water. The upper element heats the water near the top of the tank first, since it is the water that will be drawn off first. Once it heats the water in the top part of the tank, the thermostat will be satisfied and the upper element will shut off. The lower element now gets electricity and heats up the water in the lower 2/3 of the tank. Lower element works more. Under normal use, the lower element works more often than the upper element, although the upper element has priority. It would be helpful to let clients know whether both elements were in working order. Can't tell if one element burnt out. Without doing tests that go beyond the scope of a standard inspection, this is not possible. And it is not unusual for water heaters to work, but not very well because one element is burnt out. Replacement of elements is not a big job, and water heaters themselves are not terribly expensive. Okay, so there's a diagram here, and there's a label that says anode rod, electrical element in the electrical water heater. Okay, fuel supply and venting systems. We will only look at fuel supply. Venting systems will be looked at next time. Well, I guess I know what I'll be discussing next time. If I finish all of this, I'm now on slide 21 of 31. Gas-fired water heaters. We will look at different elements. Gas meter, gas piping, gas burner, combustion air, venting system. We will discuss common problems associated with each one and its implication. Gas meter. Common problems: rusting, mechanical damage, gas shutoff and locked, ice, undersized, poor access, leaks, poor location. Implications: gas leak and danger of explosion, safety issue. Unreliable or inaccurate meter. Undersized and improper function of appliances. Some inspectors check gas leaks, but this is not a requirement of the standard. Gas leaks detectable without equipment could be a serious one and should be notified. Ice on regulators. Yep, I think I had this actual problem during the summer last year. It was so hot, we just kept on turning up the AC, and then ice actually formed outside. Anyways, ice on regulators. Ice buildup on regulators can block the vents and potentially allow excess gas pressure into the house. This is most likely to happen when the meter is below the drip line of the roof. So ice causes gas meters and or regulators that ice up are usually below the edge of a roof and receive concentrated amounts of water or snow coming off the roof. Implications: ice can obstruct the vents on regulators, causing them to fail to operate properly. Under the worst circumstances, excessively high pressure gas could enter the house piping system. Strategy: if the meter is iced up or buried in snow, advise that the system be checked by the utility and the arrangement provided if as necessary. Alright, poor meter location. A, under combustible stairwells. B, with 3 feet of ignition source. Within 3 feet of ignition sources. C, below the drip line of the roof. D, in unvented locations. Alright, poor location. Some utilities do not allow gas meters. Under combustible stairwells, in unvented locations, within 3 feet of ignition sources such as furnaces or water heaters. Another poor location in northern climates is below the drip line from a roof. This can ice up a meter and obstruct its venting. Causes. This is typically an installation issue. Sometimes it's the fault of the gas appliance installer. Sometimes it's other trades who install things too close to meters or obstruct meters. Implications. The implications are gas buildup and possible explosion. Strategy. Speak to your gas company about proper locations for meters and what things can cause problems. Another sip of water. Gas piping. Common problems include leaks, inappropriate materials, inadequate support, rusting, no drip lag, missing shutoff valves, improper connections, plastic pipe exposed above grade, piping in chimney or duct system. Implications. Gas leaks and possible explosion hazard, installation issue if inappropriate materials exist, poor support can lead to weakened connections resulting in leaks. Missing drip lag can result in equipment malfunction. Missing shutoff valves may be a requirement, improper seal and connections. Oh boy, there's more to read here. Oh boy. Okay, support requirements on has... Is that right? Yeah. Wondering if I was reading the wrong spot. Support requirements on horizontal gas piping. Poor support may have weakened connections, resulting in leakage. Home inspectors should look for broken or ineffective support brackets. Also look for evidence of rusting, which is capitalized for some reason. Recommend further investigation if heavily rusted. Inadequate support. Horizontal steel piping should be supported as follows. 1/2 inch diameter piping or less should be supported every 6 feet. 3/4 inch and 1 inch piping. 3/4 inch and 1 inch piping should be supported every 8 feet. 1 1/4 to 2.5 inch piping should be supported every 10 feet. Steel piping should be supported vertically at every floor. Copper and CSST tubing should be supported as shown in the illustration above. Piping cannot be supported on other piping. Bracket supports designed to support the piping are required. Causes. Inadequate support may be poor original installation. Inadequate support may be poor original installation, or brackets may have been damaged or removed. Implications. Poorly supported pipes may have weakened connections, resulting in leakage. Strategy. As you look at the length of the pipe, look for support. Look for broken or ineffective brackets. Also look for storage of materials on top of or hanging from pipes. Gas piping should not be used to support storage. Okay. Sediment trap. The sediment trap, bracket drip lag, / dirt pocket / drip, serves as a collection area for sediment to reduce the chance of clogging gas valves or burners. Drip lag is intended to catch foreign materials before it gets into the gas valves, burners, etc. No drip lag. Causes. Installation issues. Implications. Equipment malfunction due to foreign material entering the equipment. There is also a safety issue here in that foreign materials could block a valve, preventing it from closing completely. Strategy. Look for a drip leg at the bottom of the vertical pipe going into the water heater. There should be a logical place for sediment to be trapped. Check with your utility. In some cases, utilities relaxed the Jesus. In some cases, utilities relaxed the requirement for drip legs for some time and then reinstituted them. The reintroduction is not necessarily retroactive. Be careful about what you criticize here. Again, a conversation with your local gas company is a good idea. Okay, and here's a diagram. No drip leg at bottom of flexible gas line. This is a deficiency that and should be reported. Gas shut-off valves. Shut-off valves should be located as close as possible to each appliance. Missing valves could be code violations in your area. Missing shut-off valves. A shut-off valve should be provided as close as possible to the water heater. Causes: poor installation. Implications: inability to shut equipment off in an emergency. Maintenance is more difficult if you have to look for the valve. Strategy: make sure there is a shut-off valve for each appliance. Where one is apparently missing, call for further investigation. Oh, and that's slide 31. Alright, so that was week 3's material. Oh boy, and week 4's material is 56 slides. You thought 31 was long. Even though it only took me like 40 minutes to read through all of it. And from what I see, it looks like this one has a lot more words to read out loud. By the way, once I'm done this tonight, I still haven't washed the dishes yet, and I gotta wake up early tomorrow. I gotta wake up at 7 tomorrow. Fun. Okay, just a quick little glance over all the materials here. Okay, I take that back. It looks like there isn't as much to read here, but there's just more slides. Also, let me just check one thing real quick while I have this pulled up. And, you know, it's so stupid every time I have to log back into my school material. Okay, so... One, two, three... Oh, no. What I just read was week 4's material, and now it's about to be week 5's material. So I am currently 6 weeks in, so I should have 6 of these read. And then, well, tomorrow, or rather the day this is uploading, will be week wait. Yeah, that'd be tomorrow. Yep, tomorrow will be week 7. So I have 7 weeks worth of materials to go over. And, well, my midterm is due March 1st. Online midterm due March 1st. Now, that doesn't mean I have to do it the 1st of March. I have to hand it in and have it completed by March 1st. It's been accessible since day 1, you know? But why would I risk accessing it, looking at the questions, and then realize, oh, if I close this, or if my session times out, then I can't access it again, and I get a 0 on my midterm, right? And I don't know if my midterm is timed or not, because that would suck. Like, if there's a big fat, like, 2-hour time limit on the side, that would suck. Anyways, so I just finished reading week 5's material, right? Now I'm lost. Was that week 4 or 5? Nope. What I just read was week 4. So now I need to read week 5's. Or at least get started. Let's see how far I can get. Okay, combustion air. Inadequate combustion air can result from inadequate enclosure space and lack of fresh air supply. Home is airtight. Other exhaust equipment in the area, bracket kitchen or bathroom fans. By the way, did you ever see that clip online? I think it was posted by like Inside Edition. This video of people quote-unquote burping their houses. Where every now and then you open up all your doors and windows and just let your house air out for a bit. So burping your house. And not gonna lie, every now and then I like to do that. Maybe not label it as burping my house, you know, just let some fresh air in. You know, you can't exactly do that in the winter because it's too cold. You can't do that in the summer because it's too hot. You let out all the AC. If you do it in springtime, sure, the temperature's nice, but then you might risk letting all that pollen in. And then in autumn, it's not that bad. Autumn's ideal. I mean, that's not to say autumn doesn't have some pollen either. Anyways. Implications. This can result in incomplete combustion or carbon monoxide entering the house. Strategy. Verify exhaust products. Do not enter house when hot water heater is running. Gas burner. Common problems with gas burners. Inoperative, scorching, poor flame color pattern, rust, dirt or soot, gas odor or leak. Inoperative. Cause. Can result from electrical problems, gas shutoff, defective gas valve, pilot gone out, defective thermocouple or defective thermostat. Implication. No hot water. Strategy. Report the condition and recommend servicing. Scorching. Cause. Generally the result of flame rollout or flashback. Implications. Fire hazard and damage to the control system. Strategy. Recommend servicing. Anyways, inoperative. Your operating test of a gas water heater involves using the normal homeowner controls only. In most cases, this means just running some hot water This means just running some hot water at a faucet. If the water heater does not respond, there may be several causes. These include electricity has been shut off or there is an electrical problem. The gas supply has been shut off or interrupted. The gas valve has been shut off or is defective. The pilot has gone out or the thermocouple is defective. The thermostat may be defective. By the sounds of it, the problem probably is everything's defective. Implications. No hot water. Strategy. When the water heater does not respond to its controls, simply report this condition. Obviously, you'll recommend servicing. Scorching. This may be visible at the heat roll-out shield, at the gas valve, at the wiring, or on the outside of the tank itself. Causes. This is generally the result of flame rollout or flashback. This can be the result of overfiring of the burner, lack of combustion air supply, a chimney obstruction or downdraft, underfiring of the burner. Implications. This is a fire hazard. It may also damage the control system for the water heater. Strategy. Where you see evidence of scorching, you should recommend servicing. In some cases, you won't be able to tell whether it's an ongoing problem or one that has been corrected. Let your client know this. There is usually an efficiency problem as well. If scorching is ongoing, although it is less important than the other hazards involved. I can't believe I'm doing this. Why am I reading my school material while footage of Koroks is playing in the background? Oh, did we get to the one that's with the horse yet? No, we didn't. This is it. This one took me a couple tries. Mostly because I kept missing them. Not only kept missing them, I also just, like, missed where they are. Like, I just didn't realize there was another one. But obviously, I edited those out, and you got to see the run where I did get it. I think. I'm pretty sure I didn't get it first try. Anyways, you'll see what I'm talking about momentarily. So, yeah, this is another one that you obviously need a horse to get. I don't remember if Tears of the Kingdom had any that needed a horse. Hi. Scorching. Watch for evidence of scorching around the heat rollout shield, at the gas valve, at the gas tubing, or on the outside of the tank. Gas burner conditions. Poor flame color or pattern. Cause. A completely yellow flame that is lifting off the burner or floating is a sign of incomplete combustion caused by dirty or damaged burners, poor fuel, or a draft condition. Strategy. Recommend servicing. Rust. Causes. Condensation. Chemicals used in the area. A closed dryer vent. Implications. Inefficient operation, inadequate hot water, possible gas leak. Strategy, check lower part of burner with a flashlight and mirror. Okay, that was just the bullet points. Poor flame color or pattern. Where the flame is almost completely yellow, is lifting off the burner, is not vertical, is lazy or floating, or where it wanders around on the burner, you should be called for servicing. Causes. Causes include burners that are dirty, damaged, or rusted, a poor fuel or air mixture, an inappropriate firing rate, improper draft conditions in the venting systems, bracket chimney. Rust. Causes. Rust on burners may be caused by condensation in the water heater or exhaust flue running back down onto the burner. Chemicals being used in the area of water heater, bracket paint strippers, furniture refinishing activities, etc. Clothes dryers venting into the water heater area. Implications. Inefficient operation, inadequate hot water, and a possible gas leak, if the condition is severe enough. Strategy. Use a flashlight and a mirror to look at the burner assembly for rust. You will be looking at the lower point of the water heater. It's not usually for flaking rust from the central core or baffle to fall onto the burner and obstruct it. Anyone else just not use the clothes dryer when you finish washing your clothes? Me personally, my family, we just hang it in the basement to dry. You know, we don't need our clothes to be dried immediately. Because not only is that, well, primarily it's just a big waste of electricity. Yeah, I think that was a misinput there when I jumped off of Epona. Alright, let's see this winning attempt. Obviously, you want to go slow, unless you're skilled enough to go at full speed with your horse, then by all means. So go nice and slow. And you'll start to notice that there are targets around. Don't worry about the enemies. Just focus on the targets. Don't get impatient now. Don't make your horse go faster just to make it to the next target faster. Just take your time. And I think that should be the last target. So once you hit all the targets, you might be thinking, hey, where's the Korok? Well, once you finish hitting all the targets, a balloon appears. And that's what you have to hit to get the Korok. You know, it's nice to see throughout the game, every now and then you get these really unique puzzles for Koroks, instead of the same handful. You know? Anyways. Dirt or soot. Cause. Dirt or soot may indicate incomplete combustion and can be caused by lack of maintenance or poor adjustments of burners. Implication. Incomplete combustion, inefficient operation, lack of hot water. Strategy. Documented and recommend servicing. Gas, odor, or leak. Cause. Leak in gas piping, gas valve, or pilot. Implication. Life safety issue. Strategy. Recommend immediate servicing. Venting system. Venting systems carry out exhaust gases to the chimney. Common conditions. Rust, poor slope, extending far into chimney, inadequate clearance from combustibles, improper material, poor manifolding, vent connector size, spillage at draft hood. Implications of the common vent connector problems: spillage of exhaust gases into the house, fire hazard if combustible clearances are not met, condensation and rust in vent connectors. Too much reading for one night. Alright, here's a diagram. This one is poorly manifolded and sloping downwards. You can see the condensation on some of the joints. Another diagram. This open vent connector has been this way for a long time. The exhaust has corroded a duct and has fallen loose. This is extremely dangerous and needs to be repaired immediately. You know what? I don't think I should continue. Or maybe I should. I don't know. Because I'm thinking, do I have... can I read this whole slide in 3 minutes, or should I save it for next time? The more I debate, the less time I have. No, I think I'm just going to save this for next time. So, we are stopping at slide 12 of 56. We got through 11 slides, so next time we start on slide 12, if I remember that. I should probably make a note of that. My midterm is coming up. Can you believe it's already midterm time? You know, today I was lining up for something, and I had my Pokemon Go open. This dude standing next to me, he's just like, oh, you play Pokemon Go too? So we started talking. He said that he was in the final year of high school, and he said his midterms are coming up too. Which I suppose it is that time of year. Anyways, we're almost done for this time. Yeah, you see, if I don't read my school material here and actually have proof that I went through my school material, I will never read it on my own. If you take away all my stuff, just make me sit in front of my school material, and I cannot leave until I read it all, I will still find a way to not read it. I will daydream, I will fiddle with my fingers. Yeah, I'm the last person to trust with a course that is do-it-yourself. I can't even be trusted with, you know, a course that is requirements of attending class. Sure, I attended them, but did I listen during the lecture? No. And did I go over the material when I got back home? No. Did I fail college? Yes. But I graduated at the end. Anyway, so we're coming up to an end soon. So, thanks for watching, guys. I hope you enjoyed me babbling about my school material. If it even made sense to you guys. I'm sure me watching this back a couple years from now, if I even decide to do that, I'm gonna think to myself, what am I even saying? I have no memory of what I'm even talking about. Not even no memory. I have no idea what I'm talking about here. But anyways. So, that'll about do it for this time. Thanks for watching, guys. I will see you next time for more schoolwork.